Okay, let me just have a quick check. Matar? Yeah, well, there you are. Umar? Yeah. Diana? Yeah. Priscilla? Hussein? Abdulaziz? Yeah. He will be here shortly, or he's absent. Ah, do we know what's wrong? Is he sick or something? Yeah. You might know that. Daria? Nikita? Ratami? Alex? Patrick? Mohammed K? Mohammed Omar? David? Haza? Sabrina? Vanessa? Ishpreet? Jafar? Amy? Joshua? There you are. Ray? Okay. Barak? Okay. So, just missing Abdulaziz today. Alright. Okay, so what we're looking at, just 1 hour now, although I have some of you for a tutorial after lunch, completing the square. Okay, guys. Guys, you listening? Guys, listening? Jafar! Jafar! Ready to start? Ready? Yes? Okay. So, we're having a look at completing the square. So just to get started with that, let's have a look at this example first. You can see okay? Yeah. Oh, it's a little bit kind of flickery. Uh-oh. You made it worse.
You know.
Yeah. Not great. Oh well. Expand x plus 2 squared plus 3. So that would be x squared plus 4x plus 4. And if you're not happy with that, well, you know how to multiply it out. It's x plus 2 times x plus 2. You multiply it out, you get x squared plus 4x plus 4 plus 3. So you end up with x squared plus 4x plus 7. So going this way is expanding, but going backwards is called completing the square, or CTS for short, completing the square. So what we would like to learn in this class is how to complete the square and what it's useful for. Okay, so we'll have a look at how to do that now. So I'll give you a minute and then we'll scroll down. I guess if you want, you could call this a completed square, but anyways, completing the square is the name of the process. We're going backwards. Yeah. Happy with that? Okay. Let's have a look. So it's not too difficult, it's just a little procedure. I'll show you now. I'll scroll down and do an example. So we'll do first an example that's all positive. So we'll say, I don't know, x squared plus 4x plus 20, something like this. Okay. How you complete the square? Write down 2 brackets, a square, an x plus, and we should have a number here, and we should have a number at the back here as well. So we're looking for 2 numbers. The first number, yeah, how do we get the first number?
B divided by 2.
Yeah, b divided by 2, yeah. It's half the middle number, okay? So that's half the middle number. So because that's a plus, that'll be plus 2, okay? And then the number at the back, just be careful now. I just want to be, yeah, it's going to be 16. And how do we get 16? So just look carefully. It's 20 minus, but how did you get the 4?
2 squared.
2 squared, yes. 20 minus the square of that. So 20 minus 2 squared. So it's 20 minus 2. No, hang on. Double disrespect. You're speaking when I'm speaking and you're not using English. Okay, so come on. 20 minus... I know, he's a troublemaker. You just be good and sit there and do your work. Try not to let him bother you. Don't be causing trouble, okay? Alright, 20 minus 2 squared. Is it always minus, or could it sometimes be plus?
Always minus.
Always minus, yeah. For this second one, it's always minus. Okay, we'll just do another one just to make sure we're crystal clear. X squared plus, I don't know. Let's do minus. X squared minus 6x plus 1. Okay. Well, the first part we all have. What's it going to be? Minus 3. Because it's half of the minus 6. Now be careful. At the back, it's 1 minus the square of 3. So minus 8. 1 minus 9. Yeah?
9 minus 8 equals 1.
Well, 1 minus 9.
Not minus 9, just 9.
Yeah, I'm using minus as a verb.
Oh.
Yeah, like 1 subtract 9, 1 take away 9. Yeah. I know it's a bit confusing because here you can use minus as a verb and as an adjective.
Yeah.
So...
Negative or positive?
Yeah, it would be a better, like, I try to use that, negative and positive as adjectives and minus as a verb, but I think it's good for you to hear minus as an adjective sometimes because that's how people use it here, so you just need to be mindful of that. Okay, let's have a look at a harder example. I'm sure some of you remember, these quadratics start with 1, and what do we call those? Monic, yeah. So let's have an example that's not monic. So we'll say something like, let's just say something like 2x squared plus, 6x plus 5 as an example. So what could we do to try and simplify this to get started? Yeah, not quite. I know what you mean, but we don't really call it divide 2 because it's not equal to anything, so we need a different verb. We don't say we divide 2.
Extra.
Oh, we're getting closer now. No, that's nearly. Factor what? No, not quite. Factor out 2. Yeah. I understand what you mean. Extract. We're taking out the 2. Yeah. So this would be equal to 2 bracket x squared plus 3x and then 5 over 2. Okay. So what we can do is we can just forget about the 2 for the moment and focus our attention on just this part without the 2. And we can do the same procedure. So it's going to be 2 bracket, let me use a different type, bracket x plus
1.5.
Yeah, 3 over 2 squared. Now just be careful at the back. It will be 5 over 2 minus 9 over 4, which I think is 1 over 4, is it? 5 over 2 minus 9 over 4.
Yeah, 9 over 4.
1 over 4, yeah. 1 over 4. And then the last thing to do is to multiply the 2 back in. You're thinking, where did I get the 9 over 4, is it? Yeah. It's the square of 3 over 2. So 3 squared is 9 and 2 squared is 4. So remember, the rule is you take the back number and you minus the square of this number. So it's 5 over 2 minus 3 squared over 2 squared. That's that. And we multiply in the 2. 2 bracket x plus 3 over 2 squared plus a half. 2 over 4. Okay. Right. I've done a few examples. I'll give you a little bit of a harder one to try now. So when you write that down, I want you to try this one. complete the square of, let's say, minus 4x squared plus 48x minus 146. A little bit messy, but it's good practice. Try this one. Got it? I think so, yeah. Yeah. So, let's have a look. The first thing I should do is factor out the negative 4. So that will be minus 4 bracket x squared minus 12x. And then what's the last one? Plus
73 over 2.
Yeah, it's a fraction. 73 over 2. Okay, let us complete the square in the inside. Well, it has to be x minus 6 squared. And then we need to do 73 over 2 minus 36, which is 1 over 2?
1 over 2.
Yeah. Plus 1 over 2, right?
Yeah.
1 over 2. And then we finish by multiplying in the minus 4. So that'll be minus 4 bracket x minus 6 squared minus 2. And we've completed the square now for that. Okay. So what we'll do next is look at what's so useful about this completed square. Can I scroll down? Yep. So I could say, what is the minimum value of x squared plus 4x plus 9? So you can put in different values of x and you'll get a different answer. So just, you don't have to write this piece in red down, okay? So you don't need to write the red down. But just for example, if I was to put in x is 0, what would this be? This would be 9. If I put in x is 1, what do I get? 14, isn't it? And if I put in minus 1, what do I get? That would be 5. No, 6. Isn't it? 6. Anyways, if I do this for a while, I discover all these values are above a certain number. They never drop below a certain value. Now my question is, what is that minimum value? In other words, what's the smallest that this could be? Not factorize. What we do is we complete the square. Yeah. Complete the square. So what do we get when we complete the square? That would be x plus 2 squared plus 5 will be the answer. Now if you look at this carefully, and actually I'll write it this way, 5 plus x plus 2 squared. Yeah, what is the smallest value that this could take? It could be 0, and that happens when x is minus 2. Okay, so what you have is this. You have 5 plus something which must be more than or equal to more than or equal to 0. Right, this could be at least 0. Why can it not be negative? Because of the square. So it means that this has to be, or rather I should say, this has to be in value at least the number 5. Because we know that this and this is the same. And we can see clearly when we're looking at it like this, the least it can be is 5. So we can say that the minimum is equal to 5. And not only that, we can say when it happens. This happens when x is equal to minus 2. Yeah. Whereas this part in total is 0. Yeah. Let's have a look at another example. So just before actually I continue with that, some people, or well, I think most of you know what happens if you were to plot this shape, this expression. You would get a shape like this. What we have here is this point on the graph. When the x is minus 2, the y is 5. Yeah? Yeah? It's the smallest value. This has a name. I wonder, what's it called? It's a minimum point, yeah. Also has another name as well. Yeah, it's called the turning point. Because when you think about it, it's the point where the graph turns. It's going down, now it's going back up. Yeah? Yes, much later. We'll do that much later, yeah. So, let's have a look at an example where we're looking at the maximum. So, what is the maximum of, let's say, minus x squared plus 4x plus 1? Yeah? Okay, let's have a look. So first we complete the square. Well, no, actually first we take out the minus. Yeah? Now we complete the square. What's that? X minus 2 squared, isn't it? Minus 5? And that's equal to minus x minus 2 squared plus 5. Or rather, that's equal to 5 minus x minus 2 squared. So can you see the biggest possible value it could ever be is 5? Because what you have is you start with 5 and then you take something away. What's the least you could take away?
0.
The least you could take away is 0. So this one here, we have a situation where it can be at most 5 and you can take something away from the 5. So it gets smaller away. In fact, we also know when we have the maximum. What value of x? 2 again. By coincidence, just 2. So the maximum point here, the turning point, is at 2, 5. This is the maximum. And some of you know probably already when you have a max and a min, it comes down to this guy. If the equation begins with a minus, you're going to end up in a situation where you have a maximum. And if the equation begins with a plus, you're going to end up in a situation where you have a minimum. So I knew at the beginning I was looking at a maximum in the end because the minus here, it's a trick. You know it's going to end up being a maximum because the quadratic starts with a minus. Okay? But I think some of you might have seen that before. If you didn't see that before, that's a nice little shortcut. This tells us if it's a max or a min from the beginning. Yeah?
Why is 1 to 5?
Ah, yeah. So what I did was, it's kind of like there's a minus 1 here, and I multiplied it in. So it multiplies that to make a minus, but minus 1 multiplied minus 5, that's how it became a plus. Minus multiplied minus is a plus, yeah. Okay.
Can you leave this for a minute so I can
Sure, yeah, sorry. Go ahead and write this down. Great, yeah. We'll do 2 more problems after this. You got it? Yeah, okay. Got it? Yep. Yep, okay. So, and let's have a look at a harder example now. Maybe I'd say, find B and C in y equals minus x squared plus bx plus c if it crosses the y-axis at minus 42 and has a turn-in point at x equal to 6. So what's happening here is there's two numbers missing from our quadratic. We don't know the b and we don't know the c. And I give you two pieces of information. I tell you, firstly, it crosses the y-axis at minus 42. Oh, and is it a max or a min? Max, because it starts at a minus. So it goes like this. And this point here is minus 42. And I also tell you where the turning point is. So what's this number here? 6. That gives us the turning point. Okay? So from those two pieces of information, we can fill in the b and the c. The c will be easiest to get first. Yeah, it has to be minus 42. So if you look here, you can say that when, so this is the answer, when x equals 0, then y should equal minus 42. So if we go back to this equation, we can get minus 42 equals 0 plus 0 plus c. So no surprise here. So c equals minus 42. And we're halfway finished. We know that y equals minus x squared plus bx minus 42. We have b left to get now. Okay, so let's get the b. Now, we've already made use of the 42. So now we need to make use of the 6. So the turning point is supposed to be at 6. Let's pretend we're trying to find the turning point. What would I do first here? Well, I'd factor out the minus 1. So I'd get y equals minus bracket x squared minus bx plus 42. Yes? And then what would I do next? I'd say x minus b over 2 squared plus, and then I'd stop because I realize I don't need to continue. I've done enough information. I have enough information now. Where is the turning point in this particular equation? What value of x gives us the maximum here? Yeah. When x equals b over 2, we have the maximum. Again, because we want to make this piece 0. However, we know where the maximum is. Where is the maximum? 6. So therefore, what must be the b? So we can make this, it must be 12. Because 12 over 2 makes 6, which we know should be the answer. So we end up saying x equals, that's not x, sorry. The quadratic is minus x squared plus 12x, isn't it a plus? Yeah, plus c. Now, I know this is a very hard question. I have seen it in the exam twice, so it could be something you might get. Not common, but you might get it. Yeah?
Just like in the last part.
This part here. Yeah. So, x is b over 2, because you can see that here.
Yeah.
And we also know x is 6, because that's in the question. So because this is equal to x and 6 is equal to x, you could say b over 2 must equal 6, because they're both equal to x. And then you bring the 2 up, and you can get your 12 that way. Yeah. Okay, please carefully write this down. It was a bit tricky. Yeah? Just another minute there, and we'll have a look at another example.
Sir, this question, how many marks?
You want to know how many you could potentially lose, is it? Four. Four.
If I try the differentiation method?
Yeah, that's fine, because it's unlikely that this question would specify a method. And that is an easier method, but we haven't covered it yet, you see. We'll do that at the end of the semester. It's fine. Okay, can I scroll down? Yep. Okay, let's have a look. Another example. So, the next one would be prove that 5x squared minus 50x plus 130 is always bigger than 0. So no matter what value of x you use, this quadratic is always a positive number.
The constant is positive. The constant is positive.
Yeah, but that doesn't prove that it's always positive, because this constant represents where it crosses the y-axis, right? So you could have a situation like this. Yeah, so if only life was that easy, but we can't do that. Yeah?
Can we make it quadratic, and after we need to add some positive number, and after that we'll prove that it's quadratic always bigger than
Make it. What do you mean by make it quadratic?
like we did before.
Yes, yes. So, like all problems today, we'll solve this by completing the square. So let's complete the square on this one. Okay, so if we take the 5 out, we get, or rather actually we can divide by 5 now, because we have a symbol here. So if we divide by 5, we get x squared minus 10x plus 26 more than 0. Okay, now we get x minus 5 squared. Yes? Plus 1 more than 0. And you could say it's finished here. Or if you want to be even clearer about it, you could say x minus 5 squared is more than minus 1. Now, why is this obviously true?
Because quadratic is always bigger than 0.
This is always positive, and this is always negative. And a positive is always more than a negative. Yeah? What do we write at the end of a proof?
The coordinate.
Yeah, what symbol or letters do we put at the end of the proof to mean the proof is finished? Yeah, that's the Asian way. The 3 dots, I know. The, yeah, that's okay too. QED we put at the end of the proof here, okay? Yeah. How many people did this in their home country, use this? I know some people use this, some people use this, maybe, and what was it, the 3 dots? Or,
Therefore.
yeah, yeah, so, this one here. Okay. Therefore true. Yeah. Yeah. No, but seriously, which home countries are using QED at the end of a proof? No. Ireland one. UK, yeah. Okay. And the States as well, I think.
States.
What did they use? The square?
Yep.
Okay. I guess then it's a UK Ireland thing then, so. Okay, can you write that one down? I've seen that in section A sometimes as well. It'd be a 4-mark question. Yeah. Okay, so there's about 10 minutes left. You can get a start on your homework. I think what would be good to do is part A. So 1A, 2A, 3A, 4A, 5A, and 6A. Huh? Yeah, 1A, 2A, 3A, just all the A's. 2. But we actually realized,
So it's 94.
but this is why the calculator doesn't work out as a factorize, you see. No, complete the square for proving it's more than 0.